Hello everyone, welcome back to my channel once again. So today we are going to do an important topic of class 10, that is nomenclature of organic compounds from the chapter carbon and its compound. Okay, how to name a organic compound. So we will be learning it on this video. Okay, so let's start. So when we say nomenclature, so what does it mean? So there is a nomenclature is nothing but it's a system of assigning a name to a compound. Okay, that is called as nomenclature. Matlab, if you have to give a name to a compound, so the way of assigning a name, there is a specific way of, you cannot assign randomly. So there is a way of assigning it, and that naming is called as nomenclature. And this nomenclature, so there are two systems through which you can name a organic compound. The first one is common or trivial name, and the second one is IUPAC system. Okay, IUPAC system is the standard one, and common name or the trivial system is based on the from the properties of that particular chemical compound, organic compound, or based on the source from which it is extracted. So that will define the trivial system or the trivial name of a organic compound. For example, here it is given as citric acid. So citric acid is named because citric acid is named as it is found in citrus fruits. Okay, because the source is the citrus fruits, that's why citric acid is named after the source, that is the citrus fruits. Okay, that is called a trivial name. Now when we come to IUPAC system, so that is the full form of IUPAC is International Union of Pure and Applied Chemistry. So that's the full form of IUPAC. So that's the system, that's the standard system of naming a compound, and it was first developed in the year 1947. Okay, so this is the proper way of writing a organic compound or a chemical compound in chemistry. So we follow the IUPAC system. So it's a systematic nomenclature in which the name of the compound correlates to its molecular structure. So IUPAC system is based on the molecular structure of a particular compound. Okay, so that is called your IUPAC system. So let's do the one by one. Okay, now when I say IUPAC system, okay, so how to name or how to do the nomenclature as per the IUPAC system. So you have three things to remember. Okay, first is the root word, a suffix, and a prefix. Okay, in a IUPAC system you have three parts. One is the root word. Okay, root word is the main parent word. Then you have suffix and you have prefix. So based on the organic compound present, so it will vary from each of this compound. Okay, any organic compound. Now when I say suffix, in English also you have learned about prefix and suffix. Prefix comes before, suffix comes later, right? So prefix will be before the root word, suffix comes after the root word. That way you can remember. Now when I say suffix, suffix again is of two types. One is primary, another is secondary. So primary suffix will tell you the nature of the carbon chain. Okay, whether it is single bond, double bond, or triple bond, or you can say alkane, alkene, or alkyne. So that will give you your primary suffix. And secondary suffix will define the functional group present in that particular organic compound. So if you have any functional group like ketone, carboxylic acid, or aldehyde or alcohol, so that will come under secondary suffix. And the chain that has single bond or a double bond or a triple bond, that will come under primary suffix. So in a IUPAC name you have a root word, suffix, and if you might have a prefix also. Okay, so let's start one by one by how will you name it. Now when I say the root word, so root word is nothing but it indicates the number of carbon atoms in the basic skeleton. Okay, so if you see in an organic compound, so you have a carbon chain, right? So how many number of carbons are present in that parent chain will tell you the root word. So root word is nothing but the total number of carbon atoms present in the basic skeleton of the organic compound. So you have already learned. So if there is only one carbon, then your root word will start with meth. Sec two carbons, then eth. Three means prop. If there are four, that means but. That way it will continue. If pent means 5 carbon atoms will be there. Hex we will use when there are 6 carbon atoms. Hept for 7, oct for 8, non for 9, dec for 10. Okay, till here you need to remember. So this is a basic part of the nomenclature. So you have to know the root word based on the number of carbon atoms that is present. Now let's do the next part of the IUPAC name, that is a suffix. So suffix, as we have seen, so it will designate either the functional group that may be present in the compound, okay, and it can be primary and secondary. So primary suffix will tell you whether the carbon chain is saturated or unsaturated, that is whether it is single bond, double bond or triple bond. So if it is single bond, that means it's an alkane, so it will, your suffix will be ANE. Okay, if it is double bond, then it will be ENE, and if it is triple bond, then it will be YNE. So it will end with these three, either of these three, based on the nature of that carbon chain that is present there. So primary suffix will tell you what to add, whether it is ANE, ENE or YNE. So you will write root word, then your primary suffix. Okay. So suppose if the carbon chain is an alkane, okay, all are single bonds. So how will you name the compound? So as per the IUPAC name, first comes your root word, that is the number of carbon chain. Then you will add the primary suffix. Okay, that's how you will name it. So if you see here, the first compound. So here you see, so root word is the total number of carbon atoms. So how many are there? 2. That means eth. Okay, this is the root word. Now you see single bond is there because it belongs to alkane family, single bond. So your suffix, primary suffix will end with ANE. So eth plus ANE, ethane. Okay, same way for here you see 3 carbon atoms, so your root word will be prop. Then single bond, so ANE, so propane. Okay, that's how you name a alkene. Same way goes for alkene. So alkenes means double bond. Okay, so here root word, same thing, total number of carbon atoms you see 2 are there, so eth. Then double bond is there, so ENE, so your nomenclature will be ethene. If there are 3, so prop, then double bond is here, so ENE, so that is propene. So prop plus in, propene. That's how you name an alkene. Now when you are going for alkenes or alkynes, now here it is 3 carbon atoms, so you don't have to number the position of the double bond. But when it comes to more than 3 carbon atoms, then you have to name the position of the double bond. Okay, so here how will you name it? Okay, so the position of double bond, it should be present when there are more than 3 carbon atoms. Okay, for example, you see here, so here how many are there? 1, 2, 3, 4. Now it's more than 3, right? So first what you do, you count the 4. So 4 carbon atoms means the root word will be but. So double bond means ENE will be there, right? Now your prefix, now here what will happen, you'll use the, so what will you do, so this is your ENE, so it should have been like this, right? So now but you see more than 3, so you have to name the position of the double bond. So here if you see if you count from here, this is the first carbon atom, so that means 1 dash butene. You can write this way, or there you can write but dash 1 dash in. Okay, you can put the position as the prefix, it will come before the name. So you can write 1 dash butene, or you can write in the middle also but dash 1 dash in. So 1 represents the position of the double bond. Okay, that's how you name it. Same way if you see this example, here you see here 4 carbons, same. So 4 means but, then double bond is there, so ENE. Now see the position. So it is in the second carbon. So what will you write? Either you write but dash 2 dash in, or you can write 2 dash butene. Okay, so this is either way, both are correct. So you can write in between, or you can write in the beginning of the parent word, okay, or the root word. So that's how you name an alkene. Now one more thing you remember, when you are writing the number or the position, if you are showing, then always put a hyphen in between the number and the alphabet. That's how you do the IUPAC name. Whenever there is a number and an alphabet, always there should be a dash, whether it is in the front. Suppose here it's the word is there, then also between word and number hyphen should be there, then between number and word, then also hyphen should be there. Okay, so here you see, so one word alphabet is there, here the number is there, so you'll have put a hyphen. Or if you're writing this way, so here also before 1 also there is a alphabet, Okay, so that's why you'll put a hyphen here also, and here also at the back you see E alphabet again it is there, so you'll put a hyphen in between. So you should put a hyphen, otherwise it will be wrong. You cannot write 1-butene, it is wrong. So you'll have to put a hyphen there. Okay, so this is alkene. Same way goes for alkyne. So alkyne means triple bond, right? Triple bond, so it will end with Y and E, and root word will be depending on the number of carbon atoms. So 2 carbons are there, so 2 carbons means eth, then you add the triple bond YNE, that is a suffix, so primary suffix, so ethyne. Okay, then here also you see 3 carbons, so no problem, no need to write the mention the position. So 3 carbons, so here also same, 1 2 3, so prop plus YNE, propine. So here till 3 carbons, no need to write a position because it is understood that it is in the first carbon itself. So 1 dash propine also, if you write, then also it's not a mistake, you can name it, or it is understood if you write only propine that the double bond is in the first carbon atom. You can write draw here also, or you can draw here also, both are correct. Okay, but when it comes to more than 3, then you have to name the position. So in this case, if you see this example, 1 2 3 4 5, so 5 means pent, so your root word is pent. Then triple bond, so YNE. Now put the position. So here first carbon is the double triple bond is there, so 1 dash pentyne, you can write like this, or pent dash 1 dash YNE. So this way also you can write. So both are correct. Okay, same here also, if you see, so now you see it, so here second carbon you are getting the, so your priority comes, you cannot start from here. Okay, so that is another way, it's a rule that from the lowest side you have to number the double bond or the triple bond. Okay, so from here if you see the position is second, from here if you see the position is 3, so 2 will get priority over 3. Okay, the lowest carbon chain will get the priority. So here you see, so root word is pent, 5 carbon, in second position triple bond is there, so 2 dash YNE. So either you write 2 dash pentyne or pent dash 2 dash YNE. So that's how you name a alkyne. So we have done alkene and alkyne. Okay, this is a primary suffix. I hope I am clear till here. Okay, so next coming to the secondary suffix. So secondary suffix is all about functional group that is present there. Okay, so any functional group is there, you will name it for the second, will go for the secondary suffix. So here you see, so you know the functional groups. So these are the common functional group that you need to study for class 10. So one is the halogens. Okay, halogens are fluorine, chlorine, bromine and iodine. Okay, so they are called as halogen. Fluorine, chlorine, bromine, iodine. So they are the halogens. But if halogens are there as functional group, then your IUPAC name here, they will be used as prefix. Okay, not as suffix. That's the only thing you need to remember. For prefix you'll use the halogens, remaining all you will use it as secondary suffix. If it is alcohol, you will write OL. If it is aldehyde, you will write AL. If it is ketone, it will be ONE. Carboxylic acid, it is oic acid. Okay, you know the functional groups. So for alcohol we use OH, for aldehyde we use COOH, sorry CHO, C double bond OH. Okay, or this is aldehyde. Then you have ketone, you can draw down or you can also put up. Okay, the double bond O, C double bond O, you can put it at up also. And you have carboxylic acid with COOH. Okay, we all have already done this I have already put all this in the earlier video. Okay, so these are the functional groups that you need to know. CHO is aldehyde, OH is alcohol, C double bond O, that is your ketone, carboxylic acid is COOH. So these are the functional groups. When any of this is present, then you will go for secondary suffix. Okay, so root word, primary suffix, and then comes your secondary suffix. Secondary suffix is put at the end of the IUPAC name. Okay, so these are the suffix OL, AL, ONE, ON for ketone, oic acid for carboxylic acid. Apart from that, we also have ether as functional group. Ester is also there. Okay, ether and ester. So okay, ester is this, and if you have oxygen in between a carbon chain, parent chain, then it is a ether. Okay, that's how you can identify ether, and ester is carbon with oxygen, okay, and double bond O on the top. So this part is your ester, sorry, okay. So ester is having a fruity smell. That's a characteristic of an ester, okay. That's how you can identify the different functional groups from the structure. Now coming to the nomenclature part. So if there is an alcohol, okay, how will you name a alcohol, function carbon compound having alcohol as a functional group? Now see this compound, so CH3 CH2OH. So first will be the root word, so you count the number of carbon atoms, that is 2, so that's why eth. Then you have the single bond, right? Single bond is there, and then comes your primary suffix, that is the nature of the bond. So single bond, so an, okay. Now here E will not be there, so E will be replaced by the functional group suffix. Next comes the functional group, so OH is there, that's why OL, alcohol, so OL, so it will end with, so your suffix will be OL. So ethanol, so that's how you name a alcohol organic compound. Now if it is an aldehyde, you see here, so count the number of carbon atoms for the root word, so 3, so that you have to count this also, okay. So 1 2 3, so prop, then single bond, so an, then for aldehyde we write al, so al, so combine together, so propanol, okay. That's how you name an aldehyde. Now there are common names for as I've said, so some of the common names here you have, suppose formaldehyde. Formaldehyde is HCHO, that is formaldehyde, okay. Formaldehyde, or it is called as methanol. Acetaldehyde is CH3CHO, the ethanol. It is a common name for ethanol. Ethanol is the IPC name, and acetaldehyde is the trivial name or the common name, that is for ethanol, and formaldehyde is the common name for methanol, okay. Same way acetone, so acetone is CH3C double bond O CH, ketone, okay. So that is propanon. Propanon common name is acetone, so remember this one, okay. Then we have acetic acid. Acetic acid is nothing but CH3COOH. This is ethanoic acid. Ethanoic acid is acetic acid, and formic acid is HCOOH, that is methanoic acid. Methanoic acid is also common name for methanoic acid is formic acid. Acetic acid is CH3COOH, that is ethanoic acid, okay. And benzoic acid, structure of benzoic acid is, you have a benzene ring and you have COOH, because oic acid means it is carboxylic acid, so benzene ring with COOH is it's called benzoic acid, okay. So coming back again, so for ketone, so as I said, acetone is it is called propanon, okay. IPC name is propanon and common name is acetone. So how will you write? So this is the structure, okay. CH3, so if I write the structural formula, so I have already made a video on this is a condensed formula, this is a structural formula, already the video is made, so you can have a go back and look around. So this is propanon, okay. So see here, so 3 carbons, so prop, then single bond, so an, and ketone is there, so ONE. So when I join together, it is propanon, okay. Same for carboxylic acid. If you see this one, 2 carbon, so eth, so then you have single bond, so an, and carboxylic acid, so oic acid, so ethanoic acid. Ethanoic acid common name is acetic acid, as I have already said, okay. Next comes a prefix, as I've said. So prefix is used mostly for the halogens as a functional group, or if there is a cyclic hydrocarbons. You know cyclic hydrocarbons, for example, suppose a closed structure, okay. Suppose here how many are there? 1 2 3 4 5, so that means that's a pentagon, right? So we say, and single bond, so 5 carbon, 1 2 3 4 5, so 5 carbon, so pent, okay. And it is single, all are single bonds, so pentane. Now it's a closed structure, so cyclopentane. pentene. So if a carbon chain is closed, then we go for these are cyclic compounds. If it is like this, that means it is cyclo 3 carbons, so propane, so cyclopropane. Okay, so the word cyclo is used for as a prefix for acyclic nature of compounds. Okay, so same way if you go for this one, this is cyclobutane. 4 carbons are there, so butane, but it's a closed structure, so the prefix will be cyclo, so cyclobutane. Okay, same way prefix is used for the function group of halogen. So halogens are mostly designated as X. Okay, so X stands for an halogen, so it can be either fluorine, bromine, chlorine, or iodine. So for the name that you'll use for fluorine will be fluoro, for bromine it will be bromo, chlorine will be chloro, I is iodine, so you'll use the word iodo. Okay, O should be there at the end. So fluoro, chloro, bromo, iodo. Suppose chlorobenzene, chloroethane, chloropropane, chloropropine. So that word chloro means the prefix is used for the IPC naming of these halogens. Now one more nomenclature of molecule with halogenous function. How will you name it? Okay, for example, how will you name the nomenclature of ethyl chloride? Now ethyl chloride is a common name. How will you name it in the form of IPC system? So ethyl means it. You see here it. Okay, it means 2 carbon. So you see here 2 carbon. So that's why it. Now single bond. So that is ANE. Now chlorine is there, so chlorine is the halogen, so this will be, so prefix will be chloro. Okay, so what will you write? Chloro, prefix will come, so your your prefix comes, then the root word, then your primary suffix. Okay, there is no other functional group, so secondary suffix will not come. That's how we will name it when a halogen is there. So prefix is chloro, since chlorine is there, so chloro, then root word is eth, and primary suffix is ANE, so chloroethene. So that's how you name a compound containing a halogen. Another one, okay, you see here, so how many carbon? 1 2 3, so prop, right? Then chlorine is there, so again, so chloro. Now all single bond, so ANE, so chloropropane. Okay, so now you can number it also. You can put a number position of the chlorine atom. So here you see, so it is present in the first carbon, so you say 1 dash chloropropene. Same here also you can name it, so 1 dash chloroethane, so because in the first carbon only chlorine is there. So wherever the functional group is there, from there you will start numbering. Okay, you not start the numbering from here. The numbering starts from where the halogen or the functional group is present. From there you will name the carbon chain. So in this case it will be from the right hand side, because chlorine is present on the right hand side. So 1 dash chloropropane. Another one, so you see here CH3, CH, Cl, CH3. So if I draw the structure, so it will be CH3, CH, and put the chlorine here. Now you see here chlorine is in the middle, right? So here numbering will not start from here. You can number from either here or here. Okay, either way it is correct, because from here also if you do, it is number 2. From here if you say, it will be this carbon will be carbon number 2. So always the lowest carbon chain will be the priority. So here also from 2, and here from here also it comes to 2. So you can take either of it. Okay, so it will be 1. Now chlorine, so chloro, primary prefix is there, so chloro, 3 carbons, so prop, single bond ANE, and you put the position, so chlorine is present in the second carbon, so 2 dash chloropropane. That's how you will name it. Okay, so this is the alkanes. So this is the structure of the alkanes. Okay, so that's the condensed formula. Coming to the isomers, so you can see, remember this way also how many possible isomers will be present. So for butane 2, pentane 3, hexane 5, okay, heptane 9. On isomers I will be again doing a short video. In the next video I'll show the isomer part, isomerism. I'll be explaining it. Okay, this is alkenes, some of the structures of alkene. Okay, along with the condensed formula, even the open structure is also there. That's how you name the alkynes. Okay, so now one more group is there, that is called alkyl group. Okay, so if alkenes, okay, the mostly the alkenes, okay, if one hydrogen is less, then it becomes an alkyl group. You see here, methane is CH4. When one hydrogen is lost, it becomes methyl. Okay, it ends with YL. Okay, alkyl group, so a YL. Ethane becomes ethyl when it loses one hydrogen. Okay, that's how you name it. Propyl, butyl, pentyl. So these are also present in a in an organic compound along with the main chain. The alkyl group is also present as a substituent. Okay, so if any alkyl group is present, you see what is given there, count the number of carbon atoms, and if one hydrogen is less, that means it is an alkyl group. And if you see the formula, CnH twice n plus 1. In case of alkene, it is CnH twice n plus 2, right? So in alkyl, it is plus 1. So if an alkyl group is there, how will you name the nomenclature? So same way, you see here, so that time you'll use the word alkyl. Okay, suppose methyl, suppose. Okay, okay, let me do here. Okay, so see here, so this is the main chain, right? So now if you see here, this is the alkyl group present there. How will you name it? So here you see 3 carbons, so prop, single bond, so propane. Okay, now you see the alkyl group where it is present, so first second carbon. Okay, here if you start from here also, it is second carbon, so in second position your methyl group is now CH3 single carbon, CH3, that is methyl group. So methyl, so you write here methyl will come first. Okay, it will come as a suffix. Alkyl group comes as a suffix when no other functional group is present. Now which position it is there? Second position, so you'll name it as 2-methyl propene. That's how you name a alkyl group. Okay, so 2-methyl, so in second carbon methyl position is there, and rest is root 4 plus your suffix is there, primary suffix is there, no other functional group, so secondary suffix will not be there. Okay, so let's do few of these questions. So IUPAC name of CH3 CH2 Cl is, so what will be the IUPAC name? So 2 carbon, right? Then chlorine is there, so chlorine is the prefix halogen, so chloro, 2 carbon, eth, then ane, so chloroethane. Okay, same here if you see, so this is an alcohol group, so secondary suffix will be there since functional group is present. 3 carbons, so prop, an. Okay, now alcohol is propanol. Now in what position? 1 is there, so propane dash 1 dash all. This is the IUPAC name. Propyl alcohol is the generic name of propanol. Okay, so it will not, since they have asked IUPAC name, so it will be propan 1 dash 1 all. Then for CH3 CH2 CHO, so here if you see, so this is an aldehyde group, so 2 carbon, 3 carbon are there, 1 2 3, so prop, then aldehyde group, so Al, propanol. Okay, so this is the correct option. Same here, this is ketone is there, so 1 2 3, so 3 carbons, so prop single bond, and ONE, so propanone. Here also 1 2 3 carbon, so prop single bond an. Now carboxylic acid is there, so oic acid, so propanoic acid. Okay, these are the part of the IUPAC name, how to name it. Okay, I hope I am clear with these questions. You can try this all as an exercise. Okay, try to do it. If you cannot, you let me know, I'll do this part also. Okay, these are some of the exercises that you can try it out, how to name it. Okay, write the structural formula, same IUPAC names. So these are some of the exercises that you can try it out. These are the common ones, questions, so do this all. Okay, so this structure is given, now you name the IUPAC name. Okay, now structure is given, it's the other way now, so you just have to write the IUPAC name. So structures might also be given in the exam, you have to name it. Okay, so that's all for today. Thanks for watching my video. If anything else, if any doubt is there regarding this video, comment and let me know, and if you want to see some more other topics on carbon and its compound, do let me know, and subscribe to my channel. Okay, and keep learning, enjoy learning, and have a good day everyone.